Hello and welcome back to Music 110. In this module, we are shifting our focus from demonstrating our knowledge in the form of creative work and shifting our focus to demonstrating our knowledge in the form of academic research. We're going to be doing that through this writing assignment, the Greats Writing Assignment. So that's what I'll be focused on in the lecture today, and this is what you're going to be working on this week. I would also like to remind everyone that we are also shifting our creative focus to the final project. So now that we're finished with the song assignment, we're going to shift our focus to the final project. And that even though in this module we're talking about the Greats Writing Assignment, and in the next module we're going to be talking about music notation software, you should still be getting to work on the final project. So review the prompt for the final project and start thinking about how you want to use your ideas that you previously developed in the in all of the previous creative projects, and which ideas you would like to further develop and combine as we wrap up this entire course. But let's get back to the topic at hand in this module, the Greats Writing Assignment. So today, this is what is on the menu. So first off, we're gonna go over the prompt for this assignment one part at a time. And as we do that, I'm going to be reviewing previous topics from previous modules. So we're going to review signal flow, we're going to review plugin effects, and we're going to review audio file formats, because each of these topics are going to be topics that you discuss and refer to in the Greats Writing Assignment. We will also be looking at academic research. I'll be talking about how to navigate databases and how to cite sources, because in addition to the information that I go over in these lectures, you should be supplementing that with your own research. So we'll go over what databases to look at. We'll look at some sources that will be useful to you, and we will review how to efficiently find citable passages and citable information to strengthen your writing. All right, so let's get started. In this assignment, what you're being asked to do is create a short recording, change it, put it into a DAW and change it in some way, and then write about that process. You'll then submit both the short recording that is a result of what you did in the DAW and the paper for this assignment. So two files, an audio file and a .doc file. So we're going to go over the prompt one part at a time. And in this first part, let's talk about what you're being asked to do in terms of recording audio and manipulating it in a DAW. So this is what you're going to do. First, create a short audio recording of a sound source which is 5 to 10 seconds long. So you can use your phone to do this, just like we did in the field recording project. Make a a short recording, 5 to 10 seconds long. Next, import that recording into your DAW. Choose one effect, just one effect, and manipulate the sound and the resulting sound in some way using that effect. And then it says the effect or manipulation you add to the recording should enhance or complement your original audio and should be audibly evident when listening to the finished file. Now, when I say this, right, you're not submitting two files. You're not submitting a before and an after. You're just submitting an after. So however you change this recording, it should be clear that, oh, it's that effect that they're using. It's that use of panning. It's that use of digital delay. Whatever it is, you make sure that the effect, the manipulation, is audibly evident. Once you do that, you will mix down and you'll have the audio, the 5 to 10 second audio file that is the result of your effect, your manipulation of it. And that'll be one part of what you submit. Now, let's move on to the paper portion. So, in relation to this audio file that you've created, you're going to write about it. So, in a Word document, it must be a Word document. No PDFs, no pages. Create a .doc file. You should be able to do this in whatever word processing application you use. So if you're using Microsoft Word, it's really easy. It just defaults to that. But if you use Google Docs, just make sure that you're saving it as a .doc file. Write a short paper responding to the prompts that follow. Okay, so in your paper, this paper, you're going to write 3 paragraphs, and each paragraph has a very specific thing that you're being asked to do. And you should be citing academic sources throughout. We'll discuss that in a little bit, but notice that this is a research paper. You are supposed to be citing sources to back up what you write in these 3 paragraphs. Paragraph 1. Write a description of the signal flow of your audio as it moves from an original analog sound source, is shaped and manipulated in a DAW, and is exported and stored as an audio file. Be sure to describe the original audio source and touch on all of the stages and processors inside the DAW that were involved. Okay, so you're going to be recording a 5 to 10 second bit of audio. You're going to get that from your phone onto your computer. You're going to load that file into a DAW. You're going to manipulate it in some way, and then you're going to mix that down to a new audio file. And in that process, you're going to be putting all of this information in terms of like digital audio through a signal flow. So let's review signal flow for this paragraph. So as a reminder, signal flow is the way in which audio, the path that it takes from input to output. And here we have a diagram of the complex signal flow that a digital audio workstation maps out. So in the case of what you're going to be working on for this assignment, you're going to be saving a bit of audio, a 5 to 10 second audio file to your hard disk. And you can see that represented in those kind of like if you go to the top left of this map, You can see that represented in, they look like two cylindrical shapes. So those shapes are supposed to represent what is saved on your hard disk. Now, that audio file gets loaded into the track in the DAW, and you see that represented as a waveform. That waveform then will go through, you can apply your fades and all of your in-track manipulations. That waveform then goes through the channel strip. So that goes through your effects, that goes through your panning, that goes through your faders, and then eventually is output through your speakers or is mixed down to disk. So here, as you know, to review, the digital audio workstation sort of mimics or is a virtual representation of signal flow in an analog mixer. Here we see the order in which the audio is is affected, or another way to put this would be the order of the stages that the audio goes through as it travels through a mixer. So the input enters the mixer, it goes down the channel strip. All of those knobs are filters, effects, that will then reach to the fader. All the tracks are then mixed together into the master, and that eventually goes out to your monitors. And a digital audio workstation replicates this all virtually. So when you're looking at the when you're looking at the mixer inside of a DAW, the signal is flowing from top to bottom. We have faders and knobs that are either increasing or decreasing the amplitude or gain, or are affecting whether the sound is going to come from the left speaker, the right speaker, or somewhere in between. And that the main channel sums all of your input channels into your stereo output. Now, if we're going to think of this in terms of the computer and how the DAW is, how signal flow on the DAW is interfacing with the computer itself. So the DAW is reading audio off of the hard drive. In this case, this will be the recording that you made. It's reading that audio, inputting it into the DAW, representing it on the track, visually represented as a waveform. That audio information passes through your effects, then through your channel fader, then all the way to your master fader. And from the master, the signal flows to two destinations. One is to the audio output of your computer, so out to your headphones, your speakers, whatever it is. But that audio is also the same audio that will be mixed down and saved to the hard drive if you press mix down. So once you put an effect onto this 5 to 10 second audio, the result is what you hear, but it's also once you tell the DAW to mix down to file, you'll get that result saved to your hard drive. So that is paragraph 1, how you would talk about the signal path that the audio follows and the processes and the order of the processes that the order of the processes that signal path follows. In the second paragraph of this paper, you are going to analyze the effect or manipulation you used to shape the sound. Okay, so first you're describing, right? You're like, I made this audio. This is what I did. I saved it to my computer. I did this, and then it went through these, this effect, whatever you choose. Now you're going to analyze the effect or manipulation you use to shape the sound. What factors did you consider in choosing this manipulation? How does it enhance or complement your original audio? What nature and properties of sound did you impact by making this manipulation? Did the effect you used shape the sound in the way that you expected it to? So you're analyzing now. You're both analyzing the sound itself and the processes that you used. Now, to help us out with this, let's review plugin effects. So I just have some examples of I just have some slides that I've taken from the Effects Chains lecture to review these effects. Now, you could choose one of these effects that I go over, or you could choose another effect. That's up to you. As far as this lecture, I'm going to go through this information and talk about how you would then use this information to effectively do the analysis that you're being asked to do in the second paragraph of this paper. So here we have filters. There are different types of filters, right? We have low-pass filters, high-pass filters, band-pass filters, and notch filters. And when you look at the graph to the left, that's the order in which they appear, at least those visual representations. So based on an understanding of how a filter works, you would have expectations as to what the resulting sound would be. If you have, for example, a recording of yourself speaking, you would have two different expectations if you're going to use a low pass or a high pass filter as far as expectations of what the resulting sound will be. If you have a low pass filter, you would expect the higher sounds in your recording of yourself speaking to be removed. If you have a high-pass filter, you would expect the lower sounds to be removed. Now, which high sounds and which low sounds are removed depends on where you set the cutoff frequency of the filter. So you could, based on all of this, you could predict what the resulting sound would be of a recording of yourself based on whether it's a low-pass filter or a high-pass filter and where the cutoff frequency is. For example, if you make a recording of yourself saying a series of words with the letter S in them. So, stop the slope, please, Sisyphus. And if you then put a low-pass filter on that recording and set the cutoff frequency to be relatively low, let's say uh, 200 hertz, something like that. You would expect all of those S's to be mostly removed from the resulting sound, but you would still hear the lower frequencies in your voice. And vice versa, if you used a high-pass filter and set the cutoff frequency relatively high, you could get it to a point where you would almost only hear the S's and you wouldn't hear the vowels. So this is just an example of how you would use this information, how filters work, the difference between the filters, to explain in this paragraph, paragraph 2, what you expect in terms of the resulting sound, how it will change the recording that you made. Similarly, if you were going to distort that recording of yourself speaking, you would refer to, well, how do particular types of distortion work? And here, again, as a review, by producing clipping, by squaring off the peaks of the waveform, we produce distortion by increasing the number of harmonics in the resulting sound. So based on this, you could make predictions on the relative amount of distortion to the recording of your voice, for example. Similarly, if you were going to use a digital delay, you would want to talk about, well, what does a digital delay do? And you could refer to this map here, and in referring to the delay, the feedback loop, and of course the time of the delay, how long the feedback loop is. In terms of time, in other words, the quickness and the quickness in how fast you hear the echo happen, and in reference to how the signal flow is happening within the digital delay itself, you could say that, again, if you made a recording of your voice and you expected it to echo in a certain way, maybe you wanted it to sound like it was echoing off of a very distant building, or maybe you wanted it to echo off of the wall right in front of you, and you would be changing the delay time in order to produce those different types of echoes. Now, whatever effect you use, or whatever method of manipulation, so it could be an effect, you could also change the panning of the sound source, automate panning or automate volume. It's up to you. But whatever effect or manipulation you use, you're going to have to talk about what that effect is and how your knowledge of that particular effect informed your expectations. So just as like I was talking about having a knowledge of the difference between different types of filters would lead to a discussion of how that effect is changing the original sound file or the sound of the original source, and how that knowledge is affecting your expectations. You should be referring to research in order to back that up, and in order to strengthen your argument as far as what exactly is happening to that original sound source. So let's take a quick look at the CCBC Library Research Guide for Music Production, and I can show you how you could use some of these sources to to strengthen this particular part of the writing assignment. So if you follow the link that's in the prompt, it'll take you to this page, which the library has set up for us in this class. And from from the get-go here, we have some links to some sources. Let's just take a look at these first two ebooks here. So I'm opening up Beyond Sound. And what we're looking for in these books is, let's say we're looking for something that will help us to write the second paragraph, where we're going to be discussing a particular effect and the expectations that we, and how our research informed our expectations. And let's just say that that effect is reverb. So right away, I'm just going to kind of skim the table of contents here for this source, Beyond Sound, the College and Career Guide to Music Technology. And I'm just looking at chapter titles right now over here on the right. And what I see is, okay, so the professional music technologists, preparing to be a music technologist, studying, starting your career, music technologist in live sound. So this source does not, just as I'm looking at this table of contents right now, I'm thinking this source is not for me, because really I need something that's going to give me an analysis of how effects work. So this source is really more focused on career and not on the theory of how these effects work. So let's try this next one, Chasing Sound by Susan Schmidt-Horning. And what we find is that this is a bad link, y'all. So we were expecting to find a source called Chasing Sound by Susan Schmidt-Horning, but instead we got this book, which is A Case for Critical Literacy by Alice Horning. So there is a mistake that the library has made. Obviously, the Case for Critical Literacy is not what we're looking for this particular project. So neither of these sources are particularly useful for the Greats Writing Assignment. However, if we look, there are some other pages here in this music production and audio recording page for the library. So if we, let's just move on to where we over to audio technology. And here we're going to find some potentially useful sources. An Introduction to Music Technology by Daniel Hoskin. Let's check this one out real quickly. And again, I'm going to just kind of scan the table of contents here and see if there's anything that is going to be useful. And right away, I think that it's clear that this source is going to be a super useful resource for me. Here, right, like, because we have several chapters that are just about acoustics, sound, like how sound works. We've got chapters then about audio, so digital audio software, and MIDI synthesis and sampling. Okay, great. I can also, since this seems to be like it might be a useful source, I'm just going to go straight to the index, and since the effect I chose is reverb, I'm going to just quickly check the index and see if there is any discussion of reverb in this source. And I can see right away if I go to page 105 and 106, that's where the discussion of reverb is. So let's just quickly go to page 105. Great. So here we have a source that defines reverb and discusses the how it's done in a digital audio workstation, how reverb is produced digitally. So this looks like a totally useful source, and so I recommend you guys consider this source. There are several. Let's take a quick look at some other pages here. Also under audio recording, there are some useful ebooks, modern recording techniques, and audio engineering. I've also included a PDF to another source on Brightspace. So these are all books that are academic sources that you can cite in your paper. Now, let's go back to discussing the prompt. So we've gone through the first two paragraphs. First, you're going to describe, right, what you did. Then you're going to analyze the effect and how it changed the resulting audio in the second paragraph. Now, in the third paragraph, you're going to describe how you determine the most suitable audio format to use to export your file. This should be appropriate for a web posting. Discuss the different file options and consider the size of various file types and file storage techniques. And select the best option for a small audio file that is easy to share, and specifically state the exact size of your file in this paragraph. Okay, so obviously we're going to be reviewing audio file formats for this third paragraph, and the question is about the resulting audio file, what you mix down from your DAW after the effect happens. So this is not about the original recording you made that you then are going to put on your computer to manipulate. This is about the end result, the end product. And you have options, right? So you can choose, but what you're trying to find is an option that is appropriate for web posting. Okay, so as a reminder, when we're thinking about audio files, we're thinking about the size of the digital file, and we're also thinking about the fidelity of the sound. So the more fidelity, the higher the quality of sound, the larger the file. And that's because of how digital audio works. So digital audio is represented in samples, and the sample rate is the number of samples that are happening per second, and a sample is just a moment in time where the computer has made a measurement of a sound pressure wave. Now, the higher the sample rate, the more measurements per second. The more measurements per second, the more accurate the overall result will be. But the more measurements per second, the larger the file size is going to be. So in this case, we're looking at the process of recording an analog sound, right? So that's on top. That becomes that goes through an analog to digital converter, which converts that sound wave into a series of samples of measurements. That is then converted back through a digital to analog converter, because we have to convert it into something that the computer can manipulate, and then we have to convert that back to a electronic signal that can move a speaker, right? So that becomes converted back into a digital, using a digital to analog converter, and then that is then filtered in some way to reproduce the smoothness of a analog sound. Now, when the audio goes through this process of being converted from an analog sound into a digital representation and then back into an analog sound, there are all sorts of options that we have. And when we write to disk, as a result, we have three different types or categories of file format. So the audio file format can be lossy, lossless, or it can be lossless compression. Lossy audio files are compressed. What is being compressed is the total number of bits. So these algorithms, whether it be MP3 or any other sort of lossy file type, it has a psychoacoustic modeling algorithm that discards certain information that is less important to the sound itself. So typically it's very like high frequencies. And also in terms of relative volume and timing. And so it is removing information while trying to be as accurate as possible. And it can and they remove a remarkable amount of data. So once you put a WAV file, once you convert that into an MP3, you can typically reduce the file size by something like 90% or so. A lossless file would be there is no algorithm in between. No information is discarded after the audio to digital conversion, analog to digital conversion. So that would be lossless. Lossless compression is a predictive algorithm that basically is used for streaming of audio, and it's a way to package up audio into a more compressed container and then unpack it on the other end at the delivery end. Now, when you are making decisions about what is an appropriate file type for posting on the internet, you are thinking about the file size, and also you're also thinking about the bit rate of the file. So like an MP3 file, like an MP3 file can be written at a variety of different bit rates. So a bit rate is the amount of data required to record 1 second of audio. And this, of course, would then be important because you're thinking about like, okay, so now this audio is going to be transmitted over the internet. So the same logic about how long it would take to record the audio is also applied to how expensive it is on streaming data. So when you're thinking about what is the appropriate file type, right? You'd be thinking about balancing between these considerations: fidelity, or on the one hand, should your sound file be as as high quality as possible, as close to um, the highest fidelity that you could possibly get, or on the other hand, should your audio file does it need to be smaller? So, like as I say here, certain distribution methods may require you to sacrifice fidelity in favor of a smaller size. The smaller the size, the lower the fidelity. The higher the fidelity, the larger the size of the file. This also, it's not just about how much disk space you are using for the audio file. It's also about transferring the data over a network. So that's another thing to consider. And certain distribution methods preserve the original fidelity of recording, but are very data expensive. Large files that can take much longer to stream and download and take up much more server space. So you're thinking about not just how much space is taken up on disk, but how long the transfer of that data over a network will take when you're considering the file type. So that would be what you're going to go over in the third paragraph, deciding what file type you want to mix down to. And again, you're going to be wanting to cite academic sources. Let's go back to the CCBC library page and take a look at one other set of resources, or we could, I guess I should say, let's look at some other options for sources. So we've got several ebooks here that are great and super useful, and I recommend first thinking about like what type of information do you need, and then going straight to the index of those books. So you know that you need something on the effect that you chose. You know that you need something on file formats. You know that you need something on streaming audio over networks. Those are things to look up in these in the indexes of these books. And so we have several sources here that will allow us that will help us to do those things. But we can also just do a CCBC library search. So we have those useful sources that are on the music technology page, but we can also just like do a search here for journal articles. And so what I'm going to do is, like, let's say we're going to go, let's say streaming audio. And I'm going to search for streaming audio, and I'm going to search for scholarly peer-reviewed journals only. And let's just search. Okay, so let me make sure that these are, in fact, only scholarly. Oh, good. So I thought that I had selected only scholarly peer-reviewed journals, but immediately when I started looking at some of these sources, I saw that this source is business. So this looks like it's an industry source, which is fine, but it made me think, like, did this filter actually was it actually applied to my results? Because what I'm seeing is industry sources and not scholarly peer-reviewed journals. I'm going to make sure that scholarly peer-reviewed journals are selected, and let's do this and see how this changes our results. Okay. Looks like this is in fact a scholarly peer-reviewed journal. Great. So the reason I selected peer-reviewed journals is because of the peer review process. So a peer-reviewed journal, what that means is if you're going to publish in a peer-reviewed journal, you would send in your article. The editors would then take your article. Before publishing it, they would send it to several experts in the field who would review your article, and what they would be looking for would be, one, is the research accurate? Two, is the research a contribution of something new to the field? And three, they would be making recommendations for you on how to improve the overall paper. And the result would be that everything that academic journals publish would already be reviewed for you, the reader, by experts in the field who are making sure that it was accurate, but also that it was something unique, something new. So, and this is super useful to us as researchers because a lot of the weeding process has already been done for us. So by selecting peer-reviewed journal articles, I know that I'm not going to be so worried about the accuracy of the information that I find here because it's already gone through a very rigorous process, all of this information that I'm looking at here. Okay, so here I have a whole long list, 35,000 results of sources from academic journals that are discussing audio streaming. And right now I'm looking at I'm just kind of scanning these titles here, and what I'm seeing is stuff about like the economics of music streaming. I'm seeing stuff about more stuff that's related to economics and business, but not as much about like actual like the music technology theory stuff. So I'm going to make an advanced search here, and this is going to allow me to add some other keywords to this search. So I've got streaming audio, and maybe to make sure that this really is going to focus on the actual like the audio technology theory side of things. Why don't I just try file formats and see what happens? Okay, so now I've turned my results. What was originally 30,000 hits is now 8,000. So I've helped to select down. I'm getting some really interesting titles here: a feminist analysis of mobile music streaming, authentication of MP4 files. Again, while some of these titles are all pretty interesting, I feel that I need to continue. I need to select down even more. So I'm going to go through the process again. I've got audio streaming, file formats. I could try just audio technology. See what that turns up. So as I'm kind of just skimming through these titles, this is an article that might be useful because it is more clearly referring directly to the files themselves and audio technology, rather than sort of like these other cultural considerations that some of these other titles are referring to. So this would be another way to find sources, which would be to find articles. So you've got the books that are linked to in the music technology page, but if you go to the CCBC library and you start searching around in scholarly journals, by using keywords and going back and forth between just kind of skimming titles from your from the list of titles that's showing up from the database, and just kind of adjusting keywords, eventually you will be able to find a source that refers directly to that gives you the information that you're looking for. But the place to start, rather than start here, the place to start is to start working on your paper, on the Greats Writing Assignment, and then you're going to identify what types of information do you need in order to back up what you're saying in your paper. So in this case, I'm looking for streaming audio information, but I could be looking for information about distortion, or I could be looking for information about high-pass filters or whatever. So it depends on what effect you chose, and it also depends on what argument you're making about what file type, what file format you are choosing. Last little bit of information. I've created a link in Brightspace to this page, which covers citations in MLA format. So when you cite the research you've done, you need at least 2 sources that you find on your own, and you need to cite those sources. The citations should be in-text citations, in addition to a bibliography at the end of your paper. So when I say citations in text, let's say that you found a source about reverb, and you included that in your second and you're using that in your second paragraph. So what you would do is you would have a parenthetical in-text citation where you would give the author name and page number in text. And then at the end of the paper, there will be a works cited page where you will cite the sources that you chose. You will follow the formatting that is detailed in this page, right? And you will order the sources that you cite alphabetically by author last name. So it's actually pretty straightforward. Look over the information here. There are also citation generator websites on the internet, if you look those up, that will automatically generate your citation. Just make sure that you're using the right format. There are several formats. What you should be using is MLA. And if you're using a citation generator, make sure that your sources are listed alphabetically by author last name, and make sure that you are creating in-text citations that are citing the specific page number in the body of your Greats Writing Assignment. All right, so that really kind of takes us through the whole Greats Writing Assignment. Remember that this is really just review of all these issues, topics that we've covered in the semester, and you're being asked to synthesize this information into writing and show that your ability to do research to back up your conclusions. Next week, or in the next module, we'll be looking at music notation. But as a reminder, be thinking about your final project, where you are being asked to either expand on the song project or start a totally new project. But whatever you end up doing, you're going to be combining audio. You're going to record something. You're going to be using the techniques that we went over in the sound collage, manipulating audio, and you're going to be using MIDI. So you're what you're being asked to do is combine all of the techniques that we've gone over this semester into one final magnum opus. But you are able to just build off of the song assignment if that's what you prefer. And the way that you would do that would be add audio to your song assignment, which was just MIDI. All right, so keep that in mind, and we'll see you in the next module.